implemented how we have designed. Now let's go to the live product. So this is how it looks like. So actually it is early morning. So uh, most of the states we update their data in evening. So in morning we will not see much movement happening here. But yeah, you can see the layout how we have done. So as you can see, we have given the latest update time at what time it is updated, and then we have given some quick links over here, like you can check for the testing stats, state data, hotspot directly from here, and if you want, you can share it via WhatsApp. Just to add one thing over here is that our most of the users, like I would say, more than 90% users are coming from mobile. So this layout is designed in such a way that it will look better in mobile, but still we try to make it look better in web also. So if you see it in mobile, it will give you a different picture. Yeah. So after that, we have given some quick stats, seeing from how many days we are fighting with COVID-19 in India, lockdown days, and these are the numbers like usually sample test have been done so far. This is the new number, new cases for today, and these are the total numbers. Then we have given a trend, like you can see from the initial days, so it's for last 50 days. Initially, it was very less, and now it is which is sort of very good numbers. And then we have the newly reported issues for the cases, so that we have this table, and this is for all the cases which are reported till now. And if you go down, there are this active patient per state which we have given. So at the top we have Maharashtra, there are so many cases, and then we try to do some more calculation over here. So it's this one you can see it's for the ground for the recurrent cases over here, and then problem of novel infection causes of the reported cases. So these are not for all the cases, because for most of the cases the cause are not mentioned. So what we did, we have written some let's say some automation code in backend, which will actually go through the raw data and will pull the like put in the details. So based on that, you can see how many cases happen due to domestic travel, family transmission, medical staff, how many medical staff members got infected. Yeah, there are so many, but in the data it is not mentioned. How many travel abroad, that because of that issue, how many infection happened. How many travel to Delhi, and because of that this infection happened. And then we have the infection caused by the age group. So you can see most of the infections are for the age group 21 to 30. Yeah, again, here we do not have the exact number because most of the patient this is also not updated. So whatever is available is actually this and then there is also there's a reminder how we are doing. So we are more than like 66% males are infected, and then female it's like 34%. Uh, yeah, then let me take you to the different layers. So this is what Priya was talking about. This is the main dashboard. This is a national stat dashboard. From here, let me take you to the testing stats. So testing stats is nothing but we try to pull the information like how many tests done and what is the population. Based on that, we have done this calculation. If you see the first table, it is saying sample tested per state or unit. So here you can see which state has done how many tests. So here Tamil Nadu and Maharashtra and some other states, they have done a lot of, because there are so many cases coming up. And then here is the one more critical information which you can get from here, like for the number of cases, how many tests are done per million. So per million population, how many tests they have done. Okay, and then we have this positive ratio or sample tested. So it is like let's say you have a state has done 100 testing. Out of that, how many positive cases they got? So in this, you can see Delhi has 13, Maharashtra has 16, and Telangana has 19. Out of 100, we Delhi is 13 positive cases, Maharashtra 16, and Telangana is 9. And at the bottom we have this peak which shows actually now is completely red, but initially when we started, it was green also. So we are hoping that everything will become green here as soon as possible. So yeah, this is review which state is affected a lot. So undoubtedly it's Maharashtra as of now. Yeah, so this is for this one. And coming to the next level where we have the states data. So I'll choose Karnataka because I stay in Bangalore. Yeah, so right now they have not updated the data for today because they have already stopped some night. But here we have the quick stat like how many cases were identified today, how many tests they have done, and this is like total how many confirmed cases they have, active cases recovered, and other things. Then there is one more quick stat which says test per million, what is that number, and then like confirm per million, and then confirm row test. So here you can see 1.5% cases are, or I would say 2 out of 100, 2 cases are coming positive in case of Karnataka. Then we have this trend, daily trend. So here it is actually, I mean, it's a panic situation for us because initially it was very less. Now it is increasing in Karnataka as well. And then we have this COVID curve. So if you see this for different states, so some of the states had actually flattened the curve, but then they had seen the second wave of COVID-19, which is again a worry. And then we have the sample states, sample testing done in a day, which says how many tests a state is doing per day. And then coming down, then we have the district-wise details here. So it is for new, so obviously it is zero as of now. But for total, you can see some numbers: how many recovered, how many are active, and how many lost their lives to COVID-19. Then we have this pie chart which says what is the percentage. So in Karnataka, it's moving around 52%. Then again at the bottom we have this heat map where it shows which area is badly affected and which area recovered. So yeah, this is how you can see this. So this is the next level. And then we had just, I would say 1 week back only, we added one more level, which is the district level. So now you can drill down to district level as well. So I'll drill down to Bangalore urban. Yep. So you can see here, there are not much graphs because there is not much to show, but yeah, there are some quick stats which are helpful. So you can see how many cases were reported here, and then you can see the daily trend. So if you see in case of Bangalore, initially very less cases were being reported now, but now from last 2 weeks, Bangalore also started reporting so many cases, which is sort of a worry for all of us. And because of this, containment zones are also increasing. And this is the trend for recovery, how a recovery trend looks like for Bangalore. And then this is the number which the patients who lost their lives to COVID-19. So if you see here again, we have a pie chart which says how many recovered, how many active. So initially this record was like was 60-70%, but it has come down to 48% because of this initial new cases. So now, apart from this, the main thing which we for which we started this was the containment zone. So here you can actually see what all containment zones are available for any district. So I go for Karnataka. So all these searches are interlinked. So as soon as you select the state, Karnataka, district will only show for Karnataka. And here, yeah, so you can see here there are so many areas in Bangalore. So it's like I think that today only I updated it. So it's more than 100 containment zones. And this is the whole list. But if you want to do a free search, you can do some free search over here. Like you can do like Marathali. If you type, you'll get see this. So in that case, you can see okay, out of that 100 plus containment zones, you can still drill down to more specific area. Like if you search for Marathali, it will show you Marathali. Yeah. So this was the two for this portal, and yeah, I think pretty much I covered. So Priya, would you like to add something?
Yep. Thanks, Vicky. So,
Yep.
yeah, I hope that my screen is shared and okay. Now,
Yeah, we can see it now.
okay, thanks, Vicky, for the tour, hotel tour. So, so just we are already towards the end of our presentation. So I just want to share some quick stats about the football on our portal till date. So as on June 13, like so yesterday, we had 3.6 million visits, and then the hits and the average hits you can see that for the last 10 days, like one at an average it is 1.6 lakhs. Um, and then the peak which we have seen till date is like 2.04 lakhs, and the request per minute being 120K. So that is the maximum which we have seen right now, and and of course this has given us a lot of learning at the personal level as well, because in this situation when all of us are like stuck at home and in the lockdown, and we are not in leading a normal life as we used to do, that it used to be pre-corona time. So it really feels amazing when we can touch thousands of lives, and then you see each and every visit that comes to our side, that we can still touch those lives, even though it's remote, but then you feel that yes, you're reaching out to people over there. And yeah, two more things which we both, Vicky and I were discussing yesterday, is that yes, we have realized so many things, that it's again proven that in our largest democracy, it's the underprivileged privileged life is still not here, and it's again it's always been taken for granted. And every time we look at the dashboard, it's not that it just doesn't appear as numbers over there. It literally gets translated to us as someone is still going down with COVID-19 today, and someone has won the fight and they're recovering, and somebody has lost the devices. So it's great learning for both of us, and it keeps us engaged with people, and we are happy to share this with all of you, and we would pretty much welcome the feedback from all of you. Thank you so much.
Hey, thanks a lot, guys. This dashboard really looks very informative. Yeah, I had a couple of quick follow-up questions if you guys are okay with that.
Sure, sure.
Yeah. I had a couple. Yeah. So I just was just curious on how do you verify the content? Like, you had a job to verify the content, like in your pipeline. So I just wanted to know how you verify the content. Um, yeah, because
The
yeah,
containment of information.
all the information, right? Because each of our data source kind of, for example, Twitter tells you there are like X number of cases today, but maybe economic times will tell you that Y number of cases. So how do you verify which one, which value to choose for the current number of cases? How do you verify the content?
So basically, so a lot of it is manual as of now, because we rely on bulletin just to get the initial, or to get the initial data. We look at the newspapers, because containment zone is something which is generally it generally doesn't come so early to with this. So for that we are relying on the local newspapers, because they in our, I mean, according to our observation, they are like they give us a true picture of what's happening in the area, rather than have going by the national edition of newspapers like Economic Times, and or Times of India, like so we generally try to look for vernacular version of it, because there we get the accurate data, and also the district health directorate also gives us the right information. So that verification we do via the uh, official bulletins which have been released, and we have also followed a lot of Twitter handles of the officials who release and confirm the data. So that's how we do it. So of course we do not have automated mechanism of verifying most of it, because when it is already coming via bulletin, so we get it verified from there. But then, yeah, the area information is something which needs the manual intervention.
Okay, sure. Yeah, sorry.
Sorry, I should go ahead.
Yeah, I had another follow-up question. Okay, I agree with that. So you think you're going to scrape data from you currently scraping data from the local newspapers and getting the data, right, and doing the verification.
Yes.
But two newspapers can have two different numbers, right? So we could, I mean, how would you decide? Is that a manual intervention or manipulating the system, or the code is going to do that?
No, 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 it's manual intervention, because
Okay.
we cannot afford to have automation over there. Even if we did these, we try to do it, but even if we did, it's kind of like the visitor who is actually visiting at that point in time would kind of lose trust if he knows some other source which is differing from what we are publishing.
Okay, yeah, that makes
So,
sense.
so
Yeah.
that's, yeah, that's why. Yeah.
And one question on the your data store, right? What you are storing in the database? Are you using? I mean, are you putting it in? I mean, what data store are you using for this?
It
Which
is
database?
Influx DB. It is Influx DB.
Okay. Okay.
Influx.
Did you try evaluating Elasticsearch, because this is, I think, is a read-heavy system, so this would scale well for Elasticsearch, right? I mean, did you guys
No,
try
so
evaluating?
Elasticsearch is like we are storing now. We are
Um,
actually storing it.
Right, right. So, Elasticsearch, I mean, Elasticsearch is a direct connected to Grafana as well. So, yeah, we worked on a couple of use cases for this. So, I was just curious to know. I mean, Elasticsearch again is a time series, right? I mean, it's going to be perfect for use cases. Yeah, I'm just curious to know that.
Okay, I had on the same lines. The data which you get, right, like number of, like for state you got like Karnataka, you got local. You say you get the data from the local newspapers. Now I was wondering, like, because you also get the patient data for the COVID-19, like when you have this, you have a call which you get all the data. Can't you get the numbers from there directly, which will be that be more accurate? I just curious.
So, as we mentioned, we had two different kind of data collection. So this patient data or this state data, the numbers which are coming, these are coming from the state bulletin. That is like already verified one. But the containment zones which we get, this is actually not published anywhere. So that is the data which we get from newspaper or official Twitter handle or some other news
Okay,
platform.
the other part. All right, thank you.
Also, are you hosting this on GCP or are you hosting this on?
So initially we started GCP.
We started.
Okay.
It was costing a lot. Then we moved to DigitalOcean.
Okay.
I have one question. So about extracting the data. So what are the methods that you use? Say, for example, if one can distribute that in Karnataka they have 100%, and probably in Bangalore you got there at 89%. So what are the mechanisms you use to extract the data?
Okay, so again for extracting, as I mentioned earlier, so for patient data we actually use the this crowdsourced data source, because there already effort is going on by the volunteers, where all the data, whatever bulletin data is coming, is already stored over there. So instead of doing the duplicate work, we are using that open source API for that. So that is like that is the single source of truth for us. So even we actually while this is updated, we sometimes verify randomly for some states just to validate whatever data is coming on our side, whether it is same as the state bulletin or not. And yeah, every time it is same. So patient data is coming from there, and yeah, for containment zone we had to do some I would say one or two level of verifications. And we though we pull the data from local newspapers and other places, but we still do not trust them until we verify it from some official, maybe website or Twitter handle. So that's why now we get their news from local news channels or newspaper. Then we search for those containment areas. We find out whether if the news is coming for the same area from multiple sources, then we trust it, and then we check for the official Twitter handle or some official website. If it is not there, then we drop it because we cannot trust the news which is coming from news channel or people also.
Got it. Is there any time you find that there is discrepancy between those? So, and one day data is missing, so what is your action?
I couldn't hear
Okay.
that. I think my network was bad. Can you please come
Okay,
again?
okay. Okay. Say for example, one day you find that API you have mentioned. So if probably one day API is not up, so what is your action item on that day?
Yeah, so that day our action item will be like we'll be, we already follow the daily bulletins. So the fallback option will be to get the data from those bulletins and then run a scrapper on it and then pull the data.
Got it.
We have
Thank you.
it from last 2 months, but we have not seen this scenario. So yeah, it's running perfectly fine, like I would say 100% of time.
Thank you. Is that public API available?
Yes, yes, it is. Yeah, just to add what Vicky said, I mean, there would still be some scenarios like if we had problem to the crowdsourced API. So there was one discrepancy regarding the testing data for Himachal Pradesh. So we do quick check like every time and see if everything is like everything is like going right, and because you might see a sudden deviation from what we used yesterday. So we can have that. We generally do that kind of check so that we come to know. So it was something like the Himachal Pradesh has done somewhere close to 50K test, and then in the crowdsourced data it was coming out to 5 lakhs. So in that case, of course we need to go to the state bulletin, verify it. Of course, this is such number which cannot like turn out overnight. So in that case, we do manually intervene and try to correct it.
Okay. Thank you.
Yeah, and sometimes if you see some discrepancy in the data, then yeah, we reach out to crowdsourced database team, and then we inform them that they correct it. So it's like we are working with them. We are consuming the APIs and other things, but yeah, from our end also we verify it, and if we find some discrepancies, then we update them as well that they can correct it.
Okay, so we have 3 more minutes. So I will ask two questions if others know. One is, what is the plan to get the community help if you need? Are you planning to open source it? Number one. Number two, Vicky talked about the performance thing. So what was the trick, whether it's a code or capacity tuning, which changed the timeline of crunching the data from 20,000 users for 6 minutes to 2.5 lakh or 3 lakh users for 3 minutes?
Okay, so I would like to answer the second question first. Yeah, so it was actually the code modification. So as I mentioned, initially we had no idea how we are going to plot the cast and other things. So we were putting the data in a raw format. So it's like you can imagine it like for 20,000 patient data, we were inserting the 20,000 entries, and then all the query and everything was happening on those 20,000 lines. So when we finalize, okay, we our the portal will look something like this. Then after that, we started fine tuning our scripts, and then we modified and we had done all the aggregation, everything in the initial stage. So whatever we had done, it was from the coding part. So yeah, and we were using the same computes. And second question, I think Priya, would you like to answer? Should we? Why should we open source?
Yes, so yeah, we would also like to have many hands in here, but right now, with we're not getting time because of our workload and everything. Because sometimes it becomes really overwhelming doing the same regular routine work and the work from home. everything together. So we want that we want to have very hands with. So we are planning that we can do it in phased manner. But again, here the problem comes which things to open up first. So we are still having discussions, myself and Vicky, and we are looking into the way so that there is a structure around the containment zone collection data collection right now, because that's something which is critical and time consuming, and the volunteers in that case would help us. So that is something we are trying to come up with some kind of Google sheet from where and verification links as well, so that we can very well go and see how we can inculcate everything into our system. So yes, we have plans, but timeline, if you ask me, then not pretty sure, but we would like to have it soon. Maybe I'm not sure. Maybe by end of this month or something. We would try to finalize everything and put it in a structure so that people can do it via formal channels and not facing
Thanks,
hassles.
thanks, Priya and Vicky. So you have this community behind you. So we have roughly around, not roughly, 2,000 plus members. So reach out to any one of us, or who is in your organization itself. And Anshu, me, Rajnish, we are all available. So ping us, and we can get you connected to this community. Thanks for your time. We are a minute late for the next
Thank you.
speaker.
Thank you. Thank you so much, Devansh, for having us here. Thank
Yeah.
you.
Please stay on for the next talk.
Sure.
So let Rohit have the screen. Rohit will talk about how to reduce production incidences the way Google does. Over to you, Rohit.
Hi, you can see my screen?
Yeah, we can see it.
Yeah, thank you, Devanshu, for the introduction. And so I'll be talking about shrinking production incidents. In this talk, we'll discuss service outages, how to learn from them, and how to use what you learn to set engineering priorities. Then we will discuss how to approach specific engineering tasks that target reliability weakness. Now, in this, if you have a question, there's a link you can see in the top, which is slides.app.go.gl, and give it after that. So if you visit that link, you can post a question anytime you want. So who am I? My name is Rohit, and I'm a site reliability engineer at Google. I've been at Google for about a year and a half now. Before that, I worked at multiple startups of different sizes, from a bootstrap startup of less than 10 engineers to a unicorn startup with thousands of engineers. I've been working on managing production systems for about 9 years now. As a benefit, I've witnessed problems that companies face at different stages, scale, and complexity. Today, I'll be talking about shrinking production incidents and sharing some of my learnings at Google. I'll be discussing everything in the context of SRE. So let me do a quick SRE refresher so we are all on the same page. SRE got started because Google leadership discovered traditional ops doesn't scale. SRE is the result of turning ops into a software scalability problem. At a high level, benefit of aligning incentives across business units, allowing for high development velocity while enforcing reliability. The fundamentals of SRE are error budgets, SLOs, or how reliable your service needs to be to satisfy your users. And blameless postmortems, which I'll be talking more about it in a later slide. Of course, I'm skipping a lot of details here for the For more information and background on these topics, please visit google.com/SRE. The reality is that we all work in a competitive landscape. If we fail to keep our users happy, they move their business elsewhere. When we think about the products we build, it's easy to just think about the features that we advertise. But today, I'm going to talk about the most important feature of any product, which is its reliability. Without that feature, and dare I say, none of the other features will matter at all, since there won't be users left to enjoy it. Okay, so let's look into the outage timeline and user happiness. When we talk about reliability, we talk about service disruptions or outages. In a large, complex, constantly changing systems, it's not a question of if an outage will occur. It is a question of how often and how impactful they are. Let's look at how a service outage affects user happiness and define some vocabulary about outages. In general, user happiness falls when the outage is ongoing and rises during periods of stability. So let's break down this into phases. So an outage begins, and after some time, if an alert fires and it is acknowledged, now the triage begins. So this is the time to detect an outage. After some time, the issue is mitigated. This is the time to mitigate. And sooner or later, the next outage begins. This is the time between failures, the difference between the first outage with the time between the first and the second outage. So what did this outage just cost you? There are direct costs like lost revenue. There may be people who are now frustrated with the service and they are never coming back. And some friends that people may have brought in will never become your clients. How much bad press does this outage generate? How many anecdotes, for example? So the question is, if you had the choice, how much would you pay to avoid this outage? Postmortems. Postmortems turn that question around the other way. Now that you have faced this outage, you can extract value from that payment. So let's break down this into phases. What can you learn from this outage that will make the future outages less costly? Or to put it in a way, think of outages as unintentional investments. You have unintentionally chosen to invest a percentage of your revenue in discovering that you have a weakness. What returns can you extract from that investment? This is what postmortems are for. The primary goal of a postmortem is to ensure that the incident is documented, the root causes are understood, and that the plan and that you plan and execute the work to improve the reliability of the service. That is, you need to figure out not only how to avoid the same failure, but also how to address the entire class of failures the outage represents. You should try to postmortem after each significant outage or a near miss. That is, incidents that didn't end up affecting users, but just because you just got lucky. A near miss is something like which could have ended up in an outage, but you just got lucky. Finally, it's good to recognize that writing a postmortem is not a punishment. So often in engineering, we build things because we think they are a good idea.
The recording has stopped.
Postmortems are a great opportunity to identify tasks that we can prove are good idea.
Hey, sorry to interrupt, the recording stopped.
Yeah, so I just stopped it because I think Rohit had mentioned that we don't need to record this.
Okay, okay.
Okay. So blamelessness. The the vital part is that we are all in this together as a culture of blamelessness. For example, say an on-call engineer received an alert for an outage and reacted by manually restarting servers that were running out of memory. This caused a cascading failure and prevented the remaining healthy servers from successfully serving in traffic, making the outage more severe. Now, why did the on-call engineers restart so many servers at once? Postmortem could state that restarting servers was standard practice since it has fixed so many problems in the past. In this case, however,
can somebody mute? Hello, can somebody mute all of this?
Yeah, I'll do that.
Okay. So let me restart. For example, say an on-call engineer received an alert for an outage and reacted by manually restarting servers that were running out of memory. This caused a cascading failure and prevented the remaining healthy servers from successfully serving any traffic, making the outage more severe. Now, why did the on-call engineer restart so many servers at once? The postmortem could state that restarting servers was a standard practice since it has fixed so many problems in the past. But in this case, however, the standard practice was clearly led to the wrong decision being made. The postmortem can identify the need for tooling that automates the process and ensure that sufficient capacity is always available. Maybe the postmortem will also prove that cleaning of memory leaks within the service is not threshold. In a culture of blameless postmortem, there is a basic assumption that people involved are acting in good faith. They are doing the best job they can with the knowledge and the tools they have. Assume good intentions. You could identify causes without implicating people. This means that you avoid naming any names in the postmortems. It's the on-call engineer who restarted the server, not Rohit who restarted the server. It's code submit number 3423, not Rohit's code. You get the same information, but the engineer who had to be involved isn't put in the spotlight. Because they're trying to fix systems here, not people. Remember, operations is an engineering problem. When things go wrong, look for flaws in the system that allowed things to go wrong. Now, it's important to understand that some of these fixes may still involve people. For example, lack of incident response training is a systematic problem that needs to be solved by people training in practice. The point is, if you really want to learn all you can from an incident, you need to be able to get to the bottom of things. And you can't do that if people are scared. Everyone makes mistakes. That's not the problem. The problem is the systems allow these mistakes to be damaging. once you have a critical mass of postmortems, patterns will start to emerge and you will be able to identify where you should focus your engineering effort. This is, of course, not an exhaustive list, but there are some specific engineering tasks that we have found have a strong impact on improving the three outage lifecycle phases. Tasks that improve the time to detect are about defining and measure failure. Tasks that improve time to mitigate are mostly about preparing the responders and their environment. And the tasks that improve time between failures are mostly about engineering discipline. So we'll be talking about the three different areas of focus: time to detect, mitigate, and the time between failures. We're going to shift focus here. Okay, let me just check the chat as there are few things.
Yeah, so Rohit, I think folks are not able to access the Q&A slide. It says that you have to be in presenter's organization.
Oh, okay. Mm, I didn't check that. I guess then probably we can use the chat for the questions.
Yeah, and we'll have last 10 minutes for questions. So folks, please keep your questions ready. Rohit finishes. Pose your questions.
Okay, so end of the question. So you can just use the chat. Anything else?
No, that's it. Please go ahead.
Okay. So we are going to shift focus here. So the presentation will become a less or more relevant to your job role. We'll dive deeper and discuss why each of the tasks we just mentioned is important and how to approach implementation. Those of you in the upper management might want to tune out at this point and think about how to drive in this culture, which I must emphasize must come from the top. As an engineer, it's very difficult to avoid blaming others when the management is intent on blaming you. So for those of you in the engineering and product management, let's talk details. Shrinking time to detect. When you're having an outage, when your error budget starts burning, so fast that the issue is so fast that if the issue is ignored, you will eat up all of your remaining budget. Time to detect is from the start of an outage to when a person can actually work on fixing the issue is allowed. Remember, as a person on call for the service, you can't even begin to triage a problem until you know about it. If a postmortem show a significant amount of impact to users in this phase, you need to tighten this. We need to tighten things up. We, we need to increase our SLO, fix some monitoring, and so on. So your SLIs drive your alerts. So it's important for your SLIs to give you a good representation of the end user experience. One way you can make this happen is to ensure that you're as close to the user as possible. That means, if you can, take your measurements from the client. If you're measuring a latency or availability SLI, is the latency and availability at the client side. That is what matters for the users at most. You want to include the flaky links between your client, between your service and the client. So if you know that the users need a sub 500 millisecond response time, measuring that at the client will show that you need to architect your service to deliver 100 millisecond latency at the load balancer. So this This will help ensure the flaky link between your server and your client is taken into account. Of course, some of the problems you will catch aren't your fault, but because it isn't your fault doesn't mean that you can't do anything about it. Sometimes you can't estimate the clients for metrics, and that's okay. You just need to be aware that your view of users and user experience has less precision. Another way to tune up your SLI is to verify them against external sources. A good SLI will be up when your users are satisfied with the service in real life and will be down when your users are frustrated. For example, if your SLIs show you are having a major outage, but none of your users are actually complaining, maybe you are measuring the wrong thing, talk with your users. Maybe just monitor Twitter or to find out exactly what bothers them and what doesn't, and adjust metrics to use your SLIs accordingly. Just as you iterate with your SLIs, you need to iterate on your SLOs. Your SLOs are your target values for SLIs, and you need to align them with your users' expectation. It's it is not usually obvious what your users actually need. So you should adjust your SLO target over time as you learn more. It is particularly important not to set your SLOs too tight. Do your users really need 4 nines of reliability, or they're just happy with 2? Maybe every additional 9, that is, for example, going from 2 nines to 3 nines or 99.9%, translate to about 10 times the business cost due to engineering requirements and staffing. Running a 4 nines service is not cheap, so be sure you need it before you commit your business to supporting. And finally, your alerts needs to be consistent and useful. You want alerts to fire only when actual users are being impacted. This, of course, goes back to the quality of your SLIs and SLOs. But it is important to see how good quality SLIs and SLOs directly translate into alerts that engineers learn that they can be trusted and are important. Along the same lines, you need those alerts to be both sensitive and actionable. But it is hard to get both right at the same time. That comes down to This comes down to a period of time that the alert averages over before it decides to fire. Alerts too quickly, and you will be paging at midnight for something that goes away in a few seconds. Alert too slowly, and you will be losing time you could be using for mitigating real outages. It can take some time to find the right balance. Focusing on these three like defining your SLIs, SLOs, and creating effective alerts, should get your time to detect in a pretty good shape. Now, moving on to the next, shrinking time to repair. Whereas shrinking time to detect was all technical tasks, shrinking time to repair is mostly about people, policies, training, and of course, stress management. Even if you have a good alert, what is good if everybody panics when they get a alert? In my opinion, this is the most important section to focus on. You will always have outages. You can automate fast solutions to many problems, but not all of them. You hire engineers because they are smart and creative, and they are ultimately the best resources you have for fixing the problems that slip through the cracks. Of course, they are also the slowest way to fix a problem, but they are your last most capable line of defense. So it pays to invest in them. A quick reminder before we begin this section though. An incident responder's first duty is to protect the user. During an outage, keep your focus on mitigating the effects on users, not finding and fixing all the contributing factors. So good responders, temporary failovers, version rollback, emergency request for more resources. There are bad responses like debugging a code, fixing the code, checking it in, building a binary pushing it out. That takes way too long and it's really risky too. How do you know your fix won't cause a different problem? Do that kind of stuff later when the service isn't actively burning. So what can you do to improve your time to mitigate? First, you have to train your responders. You need emergency procedures defined and tested so that everyone involved can be calm and productive during an outage. Especially, you need procedures that provide enough structure and protocol so that the response is organized. But you also need them to be open and flexible so that responders can do ad hoc explorations. And don't just train people on call, include everyone who could participate in the incident response. Devs, product managers, even CEOs. And don't just train them once. Incident response training gets rusty quickly. At Google, many teams hold weekly failure drills. These drills could be practical where we actually modify the services depending on the test. The services the services could be real user-facing systems or they could be internal replicas. The drills could also be theoretical, where a team might just talk through how to handle the situation. The drills don't have to be complex at all. A simple example could be users report that they can't log into the service. What do you do? Either way, the team gets experience with critical thinking, communication, knowing when to escalate. Number two is that you have to write alert runbooks. Some people call them playbooks. A runbook is the first thing an on-caller sees when an alert is fired. You need to write them. You need to write one for every alert that can fire. Write down things like special response procedures, link to dashboards, search queries for debugging logs, everything someone who is handling the alert might want to know. I'm not saying that you need to know every possible cause and fix before you can even make an alert, but the runbook should give the responder a clue for how to start the investigation and where to go for help. But something that happens a lot is that someone writes a runbook, but then nobody else can understand it. When you write a runbook, even if you think you're, you're just writing it for yourself, keep it simple. Write a version for yourself that just got back from a vacation and has completely forgotten how to do your job. You'll thank yourself for it. This is actually a good opportunity for a failure drill. Send an alert to a volunteer and see if they can follow the run book. Is there anything they had to do that wasn't in the run book? And then be thorough as it is just too easy to forget simple basic steps in the stress of an outage. Next, let's focus on the on-call responders themselves. Pager fatigue is a real thing. Being on-call is a hard job, and you want to keep your on-callers. You better make their happiness a priority. Over time, we have found that incident responders can handle about two incidents per shift before they start to feel overwhelmed. This, of course, will vary between teams and companies, but it's a starting point to aim for. You should automate you should automate routine operational tasks as much as possible. We call this eliminating toil. One classic example of this is release management. How much of the release process can you automate away so you don't have to babysit it? And if the load is just too high, shed, shed some of the load. Ask the developer team to handle the access pages, or maybe you need to loosen your SLOs until your service is stable enough. And finally, dashboards and logging. Measure everything is something of an SRE mode. Record every response code, every log contention event, every queue length, and then visualize these metrics on a task-specific dashboard to allow your on-callers to get the data they need to make practical decisions. Avoid on cost. Keeping metrics cost low, uh, like keeping metrics forever is not a good habit for storage. So it is a good idea to set retention limits for your metrics low for only the. So it is a good idea to keep retention long enough for only the metrics that you need for a long time. All right. You mitigated an outage. Good job. Your your users are slowly building confidence in the service again. You want this phase of cycle to last as long as possible. At Google, we have found that the most common trigger of outages is a code or a config change. So to maximize time between failures, we should just stop all changes, right? Well, that might work for a little while, and sometimes it's a good idea, like say during Christmas trees or things like that. But, but in general, you don't want changes to stop. There's always features to push, bugs to fix, new hardware to support, new threats to counter. Changes, however, can be made safer. Let me go back and fix what I just said a second ago. You don't necessarily want this phase to last as long. You want this phase to last as long as possible. There were some companies I worked with that were laser focused on this. It turned out that this was the wrong thing for them to focus on, and it's probably the wrong thing for you to focus on too. What happens if you go too long without an outage? Your on-callers get out of practice. Go when you finally have an outage, you will. The outage is much worse than it would have been otherwise. Also, companies that prioritize time between failure too highly often slow the releases down to a crawl. And this is bad for a lot of reasons, like lost step velocity and poor response time to market forces. In general, it's better to focus on shrinking your time to detect and time to repair. Maximizing time between failure largely comes down to a discipline and recognition that anything that depends on a manual process is slow and error-prone, like cowboy coding, uh, which can be very risky. Forward and backward compatible. Are the changes always backward compatible? If they are not, it poses a greater risk. The next point is the same as the first one, but it is good to say twice: redundancy. Foster a culture of quality, code reviews, test coverage requirements. And you want continuous delivery so that you can get new code out as often as possible. This way, each release will be small, Means smaller things can go wrong, and it's much easier for you to figure out what went wrong when only a few things change in every release. I want to talk about something really important with continuous delivery, and that's gradual rollouts. Gradual rollouts allow you to discover problems and roll back before all of your users are affected. We call this canary analysis. Roll out to just a few users, see how it goes, compare the error rates for those users to the users that are still on the old release. Roll out to a little more, go slowly. This is how you flatten out the sadness slope on the graph during outages. With all these filters back to the dev side as well. Since there's always at least two active versions of the code, you need the code and data structures to be both forward and backward compatible. You need your service to work when half of the servers are running with one version and the other half are running an adjacent version. Or when data stored by version X has to be read by servers running version X2. You need this not only for gradual rollouts, but also for rollbacks in general. Next is about service architecture. What makes your architecture robust? Your architecture is robust if it's continuously serving users despite significant internal failures. Think about redundancy, no single points of failures, graceful degradation. That means reduced functionality during outages, not no functionality at all. Let your architecture evolve over as you discover what works and what doesn't. When you write postmortems, think about what failed and how you can make it not matter so much when it fails again. Say maybe you have a critical dependency, then you make it non-critical. And finally, chaos engineering. Let me say I really don't like this name. We are not trying to create chaos. We are trying to create resilience. Whenever you see the term chaos engineering, think resilience engineering. Anyway, why use it? It's so you can find problems under controlled conditions, so you don't find them in uncontrolled conditions. You think your architecture is robust? Okay, poke it and verify. When I talked before, when I talked about disaster recovery testing, it was for training people, but you can test your systems this way too. And cool things, and the cool thing is, it can be all automated. You can write a test to break something in production, and what do you expect? You expect that nothing happens, at least to your users. You can keep your service architecture strong by constantly breaking stuff, and your SLOs and your service stays within the SL. So the moral of all this is let your postmortems guide you, and the investment in failures can lead you to success. Thank you. So
Rohit, I mean, he's in Europe these days. So one of the benefits of having this call virtual is we have global speakers. So any question for Rohit? Let's go ahead. Then we'll come back.
Yep, Rohit, hi, this is Gaurav. I've been working on something like desired. So idea was to add auto remediation to the platform that me and my team manages. And for that, it was also, I was thinking to have something like a desired state, which can be for the environment as well. So because as we have pipelines even for infrastructure and we have different environments like dev, stage, and prod. And for those also, like when we deploy the code, we also deploy it for the infra and for the clusters. So I was thinking to build something like a desired state map, which can be for the environment as well as other components. Like, have you had a chance to work on something similar, and can you guide or advise on that thing as well? So what we are trying to do, or what I'm trying to do in that, is currently trying to figure out what metrics would be better to put in a picture, kind of a dashboard or something kind of a group of alerts, which can tell us that the code that we have deployed, it's after that also the environment is stable, the clusters are stable, the components are stable. So any ideas or advices on similar kind of concept or thing?
Yeah, so let me try to restate what I understood. Like you have different environments, and the problem you're trying to solve is that you want to have a dashboard to understand if the changes you're making, say uh, the changes you deployed in one environment will reflect the same metrics in the other environment, and what metrics you should look for. Is that right?
Yeah,
Sure.
yeah, and later on we can use that similar dashboard or similar desired state metrics, which can help us to trigger auto remediation.
A good question. So I, I would say there's no one single answer to this, and it may depend on your service architecture and your service. Uh, the number of environments can also vary. Like they may be like dev, staging, maybe daily builds or automated builds or environments, production environments, canary environments. They can be like as number of environments as you want, and it all boils down to like how how much how how much things you want to how slow you want to go to flatten the sadness curve. So this non-prod environment should reflect the prod, but it is definitely not always the case. So there will always be surprises when you roll out the prod. That is for sure. There are few things though you can do. That is like say if you have a major change coming up, you can have say a launch plan or a launch review, which is like in which you document all your critical things like how you're planning to roll out, what metrics you expect uh, uh, what you expect to go to happen. Like what are the metrics you say you have a bug fix for latency improvements. By how much percentile you expect the metrics to improve, and so on. What is what are the risks which can happen? Like maybe the latency instead of decreasing increases. What is the safe rollback plan? And of course, gradual rollouts is another thing. Which is like you roll out to a few users, and then you roll out to more users. Now, there's also another thing which you can think of, that is, are you using the same tools for both production and non-prod deployments? That would also kind of keep the difference between prod and non-prod less. Then there may be also situations like you could also serve some of your traffic, say 1% traffic or 5% traffic from your say a pre-prod environment or a staging environment. Yeah, things like that. There are multiple things multiple angles in which you can look at to reduce the impact of your change. Does that answer your question?
Yep, I think that would be helpful in that scenario. Thank you.
Any more questions for Rohit? Okay, so in the interest of time, so what we will do is the event comment section is open, so you can post your questions there. And I think for a couple of days, Rohit can keep an eye on the event comment section. And if he finds a questions, that he can write over there. And any other format of Q&A between listeners or the community members and the speaker is open. Anshu, would you like to add something, or Anish?
Devanshu, Digital here. Sorry to interrupt before Anshu pitches in. So this is regarding the chaos engineering. So one example for this is the chaos monkeys used by Netflix. So are there any models which actually suits say medium-sized organizations or the other organization, and in what all levels we can implement this chaos engineering part? Are there any particular models already available for to try it out, especially when it comes to disasters and chaos and things?
Yeah, that's a good question. So the thing is, I'm not used Chaos Monkey personally, but I was a big fan when I was using AWS, even though I didn't use it. The thing is, Chaos Monkey is a tool, and there can be different kinds of tools. Even Amazon has multiple kinds of Chaos Monkey, like Chaos something. They have a bunch of things, as I remember seeing somewhere in the article. I don't remember exactly the names. So the tooling will depend on your environment, your deployments, and so on. So, for example, if you're not using AWS, and if Chaos Monkey is only available for AWS, maybe it will not serve your purpose. So they can be different tools. But the basic idea is like you have some theories. That is, say, for example, you have designed your database, or you have deployed your database in a highly available environment, which is like, say, one of the servers go down, you don't lose, your service is unaffected. So one of your slaves go down in a MySQL environment. But have you tested it? If you can, say, plan a week or few days and dedicate and just say we're going to test some failures, some theories of which should not impact production or the users. If the on-caller notices nothing, or whatever they notice does not affect users, everything is fine. The query is tested. And if it affects users, probably you have a quick rollback plan, and you have a bigger return on investment. That is, what can you do to make sure that does not happen again. Like the theory holds true when the real outage happens. Yeah. So, for example, say you have a lot of time. What happens is that you may be over delivering than your promise. Say you have SLO, internal SLO of 100 milliseconds, for the API to respond, but you're always delivering at say 15 milliseconds. Now, with now, what happens if the service actually starts responding at 100 milliseconds? It may lead to a lot of different surprises. So, maybe for example, more number of connections need to be handled simultaneously at the same time. That may that may increase say 20-30% load on your servers, and maybe you don't have enough servers provision to handle that kind of load, and yada a lot of things can one thing can trigger the another, and you have a major outage on board. So you can have a you can create a test plan or chaos engineering plan to test this theory and decide which tools you can use for that. Does that answer your question?
Not really to the extent I wanted, but it's okay. In the interest of time, I will also do more research and let's see I can get back to the same forum. Thank you.
If there's anything specific you want, is there anything specific you want to be addressed?
Yeah. So specifically in the sense, so some of the chaos part, the chaos engineering part is limited to the applications in my understanding, not to the extent of software defined networking or database level and things like that. So that is what I'm more interested in. So how chaos engineering works in the software defined networking, virtualization, and, more than the application on the database and other things.
Okay, I think we don't have time to answer that. Probably Rohit is interested to answer that, but we really don't have time. So we'll park this question for the community discussion on the bottom of the event. You can put a comment and then Rohit address.
Yeah, I can keep in touch with you.
Okay. Sure.
Thanks.
Thanks, Rohit, for joining this. And this is like our new normal now. So we are roughly we went up 36 people here. I think 38 people here, and then the streaming with Anshu's hack. Finally, we are able to stream, and this last talk was streamed. So with that, we have a backup. So we have this event backed up in a stream, and the previous one in recording, which is which is good. So we started our discussion with COVID. So I would like to end this meeting with sharing a link and a screen of mine. What I've done. It's once again to help the whole of the scientific community. Let me try to share my screen. Yeah. Can you guys see the screen now?
Can we can see now.
Okay. So
we see you. Oh, okay. Yeah.
You got it? Yeah.
Yeah.
So this is our this is called folding at home. So you know, all DNA, all viruses are basically proteins, and this is RNA virus which we're dealing with, and proteins fold. And to design a drug, you need to do the modeling to identify how many ways that protein can fold. So this is a hugely computationally complex task, and this guy is folding at home has actually done a great job. So you have a small program which you can install in your machine and share your CPU, unused CPU resources. I think the audience here never shut down there. Okay, be it their personal computing device or be it their official. So and they do go to sleep. So those compute cycles could be donated to the scientific community very easily. So what I created is from our group, we have created a group. So if you see this part, the team identification, this is a team which I created for this GitHub community, the large scale engineering production engineering India forum. And I have written in our Tumblr, I have written a small post about it. So I'll just put up that. Yeah. So how to join this report is covered here. And with this, I would like to end the session. So let's join hands together, share your compute to fight COVID and other related stuff in helping the drug design faster. So with this call, I would like to start from my end. If Anshu, Rajneesh, or Orko have some closing comments, please go ahead. I will stop sharing my screen now.
Yeah, so just quickly saying, right, I think...
Yeah, Anshu.
But it's been an interesting time, right? Like we started off in last session doing this remotely. Like I was saying that today at least we have Rohit who is joining us from 3 hours time zone away, but otherwise think of it that, hey, we are all sitting about 45 minutes of Bangalore traffic, 5 maybe 10 minutes of nighttime traffic. It kind of brings on to a different dimension as to how we'll continue going forward. So yeah, today's was another interesting session where we learning about the entire COVID scenario, or rather how some of the teams are presenting these data sets, right? And everything that Rohit spoke about. These two topics I think were definitely interesting, and I'm sure will be helpful for the community as well. I think going forward, what I would suggest or recommend to the rest of the folks on the call is that whatever they are doing, I'm sure it would be of interest to the rest of the community as well. So please do reach out to Devanshu and rest of the organizing team via the meetup page and recommend what talks is it that you would like to present, or what talks is it that you would like to see, right? So yeah, that's what I would like to say. Yeah, that's all from my side. Thanks.
Yeah, I think I want to say a big thank you to the presenters and the attendees. You have spent time. So keep doing the awesome work and keep the world running, because it's our job. So I think big thank you to everyone who joined and shared their findings and learnings and the awesome job they do. Thank you.
Any passing comment?
Nothing. I'm good. Like as usual, I always I get to learn something new every time I come here. So that's why I'm here. And I guess it's the same thing for other folks also. Every time, every LSP I've attended, I've always learned something new. Thanks for the presentation, actually. It was really good.
Yep. Thanks to the presenter. Thanks, Walmart, also, and Gaurav for hosting us. So we'll be regular on this. We can increase the frequency. We are actually planning to increase the frequency of the event, because meeting online is becoming easier. So we'll keep you posted. So we have multiple channels now to follow. One is in LinkedIn. Rajneesh is managing. YouTube, Anshu has created our separate channel. So we'll post some old videos there. So do get in touch, and obviously Meetup and Tumblr are there since way long. Once again, thanks the presenters, thanks the participants, everyone, and thanks Walmart for hosting the event. So Gaurav, I would like to end the session. So everyone can unmute and set up clap for everyone. Please unmute and have a round of clap.
Everybody.
Thanks, guys.
Thank you. Thank you.
Thanks, everyone. Thanks. Bye.
Have a good day and stay safe. Stay safe and good weekend. So, yeah. Thanks, everyone.
Thank you. Thank you, everybody.
Everybody.